Hola clase. Today we are going to go through the proof of the quadratic formula. And as usual, we're going to try to do it in only one screen under 10 minutes. Let's see if we can do that. Now, before starting, there are a couple of things that I need to know to make this work. First is to complete the square, and then how to recognize quadratic equations, which, remember, are those that have a quadratic term, a square somewhere, and they look like ax squared plus bx plus c. Okay, we're going to start with a generic quadratic. We don't have numbers, only coefficients. Ax squared plus bx plus c equals 0. And we want to solve this. The first step, I want to leave the x squared with a coefficient of 1. So I'm going to divide everything by a. And of course, it's going to happen here as well. Not that it's going to change the 0. So from there, we're going to leave an x squared here, and everything else, it's going to be divided by a. The next step for us is going to be moving the independent coefficient to the other side. So we leave only terms of x in this side. And this lets it ready to come here and complete the square. Now remember that completing a square comes from how you expand a binomial. Square of the first plus 2 times the first times the second plus square of the second. If the first term of that binomial, it's an x, let's leave the b in the same place, you're going to have x squared plus 2 times bx plus b squared. Now this b squared, it's a number, and it's going to be half of the 2b. In your case, our case, half of this term here multiplying the x. So what we're trying to do is going, okay, if I've got the x squared and I've got the b over ax, what do I have to put here as a something square? So I can put it here when I contract that binomial again. So it's as simple as dividing that term times 2. In our case, b over 2a. With that information, I can come here and add that term of b over 2a square here to allow me to have a perfect square there. Well, of course, if I've got it in one side, I need to put it in the other to keep everything balanced. So I'm going to put it in the front because we've got a minus there. That means that in this side, I will have a perfect square of x plus b over 2a. And in this one, we're going to try to leave everything with the same denominator. So the common denominator here is going to be 4a squared. And, excuse me. And that's going to leave us with b squared minus 4a squared over a is going to be 4a times c. Now it's beginning to take shape into something that looks familiar, because now how do I get rid of that square to isolate the x? By square rooting. And again, if I do it in one side, I'm going to have to do it in the other. So now square root has 2 possible solutions. I'm going to have here square root of b squared minus 4ac over 4a squared. In here, I'm going to be left with what's inside of that square. The next step, it's simply isolating the x, moving this, subtracting to the other side. And now, if we want to simplify these two fractions and leave it as a one fraction only, That's actually very straightforward because the square root of 4a squared is 2a, which happens to be what I've got there. So now x equals minus b plus of minus square root of b squared minus 4ac, all of that over 2a. And we solved a quadratic equation just by substituting the coefficients. This happens to be the quadratic formula we know and love, and it's ready to use anytime that I've got these values for a, b, c already. Okay, so now it's your turn to go and practice. Thanks for watching.